Once the dry steam leaves the superheater, it is directed to a steam turbine. It is flowing through towards a steam turbine. But in its path, there is a valve which is placed there to control the amount of steam which is passing on to the turbine. And by amount, I mean the rate of flow. So the amount of steam that is allowed to enter into the turbine will directly control how fast the mechanical speed of the turbine will be. And by extension, it will control how fast the generator will move. So by varying the amount of steam which is coming into the turbine, we can adjust the speed of the generator. Why will we require to do so? I will explain in a little bit. So when it enters the turbine, this steam has heat energy, and its heat energy is converted into mechanical energy inside the turbine. When the steam is allowed to expand in different stages of the turbine, it is incident on the blades of the turbine in different stages, and the blades start to rotate under the influence of steam flowing around them, and the heat energy of the steam is also converted into mechanical energy, and this causes the turbine shaft to rotate. Once the steam uh, uh, um, has completed its journey inside the turbine, it leaves the turbine, and this is called the exhaust steam. And this exhaust steam is then fed into a condenser. We will discuss how this condenser works in a short while. So in this condenser, this exhaust steam is converted back into the liquid state, which is water, and if need be, then some water is uh, fed into this loop to make up for any losses of steam inside the plant. And then this water is pumped back to the by the feed water pump, which increases the pressure of the water again into the feed water heater, which uses some steam from turbine to preheat the water. Then it flows into the economizer, which further heats this water using the flue gases from boiler, and then it is fed into the boiler, and then it goes into the boiler, and then it is again converted back into the steam. Sometimes we need a condenser, a cooling tower in the steam power plant to ensure that we can provide cool water inside the condenser so that the steam which is entering the condenser can be condensed. So sometimes we require that cooling tower, and that cooling tower then is then used to cool the water which is coming from the condenser, and then that water is mixed with the water from the river, and then it is recirculated through the condenser, which condenses the steam which is coming at that point. Going to the alternator. So now I'm going to talk what I meant by controlling the speed of the alternator. So the alternator is coupled to the turbine shaft, and its shaft rotates at the same speed as the turbine shaft. So it has an exciter, and we are going to go into details about it in later on, or you can find details about it in machine's book. So this alternator then produces electrical energy, which is fed into the transformer, and there are some certain circuit breakers which are able to break the circuit and discontinue the supply if there is any problems, and there are some isolators switches as well. But then this electric power enters the bus bar. I'll just briefly introduce these components. So the circuit breaker is a device which acts upon the signals provided by a relay. A relay is a device which senses if there is a fault or not, and then if it detects the fault, it generates a trip signal which is passed on to the circuit breaker. When the circuit breaker receives that trip signal, it immediately opens up its contacts using various mechanisms, and then the fault is isolated. But sometimes you do not know if the line is de-energized, if the circuit breaker has operated or not. In order to ensure extra safety, there are certain switches which can be operated manually by the utility staff, and these are called isolators. So the isolator switches can be operated manually, and these are just after the circuit breaker has operated. So after the circuit breaker has operated and the utility personnel go there to check the fault or to reset the circuit breaker, then in order to ensure that they do not touch a live wire, what they do is they first of all they throw these isolator switches. So they try to open these isolator switches. If the line is still energized because of failure of circuit breaker, then there will be sparking and they will not open the line, and they will know that the line is live. But if there is no current, then there will be no sparking, and the isolator switches will further ensure that the line is not live, and this is for the safety of the plant personnel. Bus bars are normally those lines which flow throughout the plant and to which the power is fed. So uh, then we move on to the speed control of alternator. So if the load on power system increases, then the load on alternators increase, and if you load anything, it slows down. So this speed of mechanical speed of the alternator slows down under the influence of overloading. When it slows down the speed of the turbine, which is detected, and a command is sent to the valve to increase the rate of flow of steam. The steam is allowed to enter, more steam is allowed to enter the turbine, and the speed of the turbine increases. When the speed is back at the steady state or back to its normal value, then the valve is held in that position. So this is how the speed control of alternator works. Speed control works because, as we all know, that speed of the alternator will decide what frequency, what is the frequency of the voltages it is producing. So we have to keep the frequency constant at 50 hertz, and that is done by control of valves. So as I have already told you that the condensate, the thing which has been condensed is called condensate. The thing after condensation process is called the condensate. So water over here is referred to as condensate. The condensate is used from the condenser. The condensate is pumped into the feed water, is used as the feed water, and it is pumped back into the boiler. So some of the water may be lost during this cycle via leakages in various components, and this is replenished by this river. And before this river water is passed on to the feed water pump, it is treated in the water treatment chamber using aeration and using various processes: sedimentation, coagulation, and filtering. And it is also subject to aeration and degasification. So multiple processes are happening inside this water treatment chamber, and pure water is circulated into the system. So this feed water heater, as I have told you previously, they preheat, and this economizer, they preheat the water before it is being fed into the boiler, because um, the steam is normally lost inside this plant in, let's say, in a condenser. When it is precipitating on the condenser pipes, some of the water may not fall down. So some of it is lost in valves, so, and leakages in pipes. So there are multiple points where steam can be lost. So cold water required for condensation is acquired from nearby water source, and hot condensate is discharged at some distance in the same water source. So when there are no cooling towers, then sometimes we discharge the hot water from hot condensate um, at some distance from where we picked up the water in the same river. But normally there are cooling towers in large steam power plants. So hot condensate is sometimes pumped into cooling towers, which use some sort of fans, induced or forced draft fans, to cool the condensate steam. And this is done when water is scarce and you have to reuse that water, um, and you want to minimize the usage of water. Let us talk about how this site should be selected for steam power plant. Number one is very obvious. You have to select a site which is near a coal mine to reduce transportation costs. And if it is not available, no nearby coal mine is available. So this indigenous word means local to something. So if coal is not available locally, you have to ensure that there are adequate transportation infrastructures and logistics are there, and that they should be in place to move coal from the coal mines to the place where you are going to install the steam power plant. So you have to ensure that the infrastructure is there. Number two, it should be located near water source, and that is very obvious as well, because you need water for condensation needs, and you will need water so that it can be pumped into the boiler to make steam. Uh, Obviously, this third point comes under the purview of coal mine. That the first point, that the site should be well connected to other parts of country by rails and roads. For obvious reasons, you have to transport the coal. The land must be cheap and readily available if extension is desired. So you have to select a site where land is cheap, number one, and number two, it is readily available. So that if after, let's say, 2 to 3 years, you need to extend your plant, you can easily acquire more land in the vicinity. uh, that should be the top priority. And number two, the thing about land over here is that it should have strong foundations. Whatever land you choose, it should have strong foundations, so that if you build on top of it and you place heavy equipment on top of that land, the building does not settle. Number five, it is better if your plant is located near load centers. For what reason? For the reason that there will be lower transmission losses, like there will be lower losses in the transmission lines. However, the smoke and fumes which are produced during the plant operation, they necessitate that these plants are located away from populated areas. So on one hand, you want the plant to be located near the load centers, near the population area, so that the power can be produced and distributed on short transmission lines, reducing losses, reducing expenditures. But on the other hand, you need for the health of people living there, you want to locate it away from that. So normally, transmission losses can be controlled by other means as well in an AC supply system. So our priority here is to choose an area which is located away from population. So the conclusions are, you have to choose a site which is away from load centers. It is near a water source. It is well connected to other parts of city via rails, roads, etc. And you have to select a site where land is cheap and readily available. So this is what can be concluded from all of these points. Now let us talk about plant efficiency. So the efficiency of a steam power plant is in its raw form is quite low. It is about 29%, which is very low efficiency. This is because majority of heat is lost in the condenser. So you have a exhaust steam which has a high temperature, and you want to convert it into water again. So you have to release a lot of heat energy which is present inside that steam turbine. Now, if you do not use that heat energy and you just dissipate it, then obviously that energy which was used to make that steam, that portion of the energy is wasted, because you have just thrown it away to convert the steam back into water. However, if you use the plant in a combined cycle arrangement, and what is meant by combined cycle arrangement? The combined cycle arrangement. Let's say if the exhaust steam is used to heat a certain parts of the building, so that is called combined cycle arrangement. You use the heat energy in the exhaust steam for purposes other than production of electricity. Or strictly speaking, that is called cogeneration. Combined cycle arrangement means that you use the steam which is pretty heated up and transfer its heat into, let's say, some smaller steam power plant, to which then produces electricity. So you can do a lot of this stuff. I think the best purpose, the best arrangement for a steam power plant is that combined cycle arrangement is not a best arrangement. Normally, if the steam you can say combined cycle arrangement is also best, because normally what is done is the steam turbine power plant, power plant is used in conjunction with the gas turbine power plant. So gas turbine power plant uses gases to run its turbine, and then it releases those gases. So those gases are they have a high heat content, like they are at a temperature of say 1500 degrees Celsius, and you only need about 1000 degrees Celsius to convert water into dry steam. So you can use those exhaust gases and transfer their heat energy into the water, which is used to produce steam, and then that steam can be used in a steam power plant. So that is how a steam power plant is used in a combined cycle arrangement. And cogeneration is the most important application of in this case. So over here, what I meant is the heat loss in condenser can be avoided if we use cogeneration techniques. And by cogeneration, I mean using the heat energy in the steam, exhaust steam, which is fed to the condenser. You do not feed it to the condenser. You use that exhaust steam to heat something else, which is not going to produce electricity, but just some process which needs heat. You use this exhaust steam in that process. That is called cogeneration. And because it is different from combined cycle arrangement, because you are not using that exhaust steam to generate electricity, you are using that exhaust steam just to provide heat to some non-electrical process. So coming back to our topic, so obviously some vacuum is also created in the low pressure stages of the turbine, because when the steam passes through the turbine, it expands, and when something expands, it loses heat. When something loses heat, it regains its original state, which is in case of steam, water. So some of it is condensing. So some portion of that steam is condensing inside the steam turbine as well. And when the steam is condensing inside the steam turbine, which is enclosed from all sides, then gaseous steam occupies more space than the liquefied steam. But there is no air to replace that space which was created. So there is vacuum in that space. That vacuum facilitates the intake of air if there are certain small openings, which you can call leakages. So those leakages of tracks will allow the air from outside to flow into the turbine. When air will flow into the turbine, it can cause damage to the turbine because a lot of fluid is flowing through the blades of the turbine, and if any air bubble is kept trapped in between the blades of the turbine and the oncoming steam, then it can burst and cause cavitation on the blades of the turbine. By cavitation, I mean that there are some certain, the blades are eventually destroyed, but progressively they are a certain holes start to appear in them. So next we talk about thermal efficiency of the plant. It is the ratio of heat equivalent of mechanical energy transmitted to the turbine shaft, which is the output of the turbine. Like mechanical energy of the turbine shaft means the speed at which it is rotating. You convert that energy, like in Newton meters or joules, into the kilocalories. So that is the heat equivalent of the mechanical energy transmitted to turbine shaft, and it is the ratio of that to heat from coal combustion. So the initial heat which was released from coal combustion, that is in the denominator. So it is also calculated as the product of boiler and steam turbine efficiency. So if you know the steam turbine efficiency and the boiler efficiency, you just simply multiply them and you get the thermal efficiency of the plant. Otherwise, if you want to calculate it, you can also use this definition. So typically, thermal efficiency of a plant is 30%, with 1% of it is lost when the in the generators, because typically the efficiency of generators is around 90%. So 1% of this will be lost in them. So it means that only 30 kilocalories are available at the turbine outputs if 100 kilocalories were generated at the. Overall efficiency of the plant is the ratio of heat equivalent of electrical output. So if you convert the electrical energy in kilowatt hours into kilocals, then that is the heat equivalent of electrical output. And if you take the ratio of that to the heat from coal combustion, you get the overall efficiency. And normally 29%, it is 29%, since 1% of it is lost in the alternator.